amount of information that I can share with you, and I like to share. What I'll try to do is to refrain from real technical details, because they're interesting for designers, but they're not so interesting for those who listen to music, because at the end of the day it's all about the music, and we say it's all about the music, and we mean that, and we're very serious in approaching how to design a playback system like this. We have a background in the pro industry, where actually our first product was the 81, an analog to digital converter, which was developed in 2004 and put on the market a year or two later. By then it was the best converter in terms of signal to noise ratio and distortion. It's a fully discrete design, so we didn't rely on industry solutions from Crystal or TI or whatever chip maker. We have a discrete converter. Today it's still the best converter on the market. There's a bunch of recording engineers using the converter, mainly in classical and jazz, and that's our actually first step in what we call a window on the music. What we aim for as a company is to provide a very transparent channel, so to speak. In this case it's an electronic acoustical channel, from what we say ear to ear. We would like you to be able to literally look at the artist and see what he has meant in all aspects, tonal aspects, emotional aspects, dynamic, whatever he creates. We don't want to touch that. We want to step outside of the message that's actually made by the artist. And to do so, we develop a system with a few approaches in mind. And these are low distortion, these are linear behavior in terms of frequency and phase, so the time behavior, and again low distortion and low distortion and low distortion, and so on and so on. And that's not only about harmonic distortion like you are used to in amplifiers. We go much further. One of the other distortion sources in analog to digital and digital to analog systems, like the LS1 system, is jitter. And we have a track record when it comes to making low jitter systems. And jitter induces a very nasty type of distortion, which is very, very audible. And when it's very, very audible, you have to go really far in reducing jitter to ultimately low levels. And we went that far that we had to develop our own measurement equipment 10 years back to actually measure the performance of our oscillators, because the available equipment on the market was not good enough. So that's indicating a little bit how serious we are when we mean low distortion, low jitter, and so on. Now, onto the LS1. The LS1 is a fully integrated playback system. We call it a playback system because it's much more than a speaker. It includes converters, filters, and amplifiers, and actually all you need is a source. And the LS1 accepts digital sources like a CD transport, like a streamer, like whatever puts out digital. You can also connect to USB, and it also has analog inputs. Today we're using analog inputs together with a totally cool vinyl player with preamps from Audio Research. But you can also play back files from a streamer, and then you use the digital inputs like we do here as well. That's from the, say, feature and functional part of the design. A few words about acoustical design. This is what we call a wide baffle design, and the main reason to making a wide baffle is to provide a very directional behavior of a speaker. If you do so, you actually radiate less energy to the sides of the speaker, and that means less reflections. And less reflections is always an improvement in stereo imaging, in accuracy, but also in the type of freedom of stereo image if you move around the room, regardless if you sit or stand up, left, right, front, back, you always have this very nice image of music. And that's actually a sign that the reproduction of the music has taken place. It's not out of a speaker, it's here in the room. And that's what you want. You don't want to listen to a speaker, you want to listen to the music. And the wide baffle helps for that. One other aspect are the rounded corners, which helps in avoiding diffraction. If you have a sharp edge, you have a traveling acoustic wave, it suddenly enters a much bigger area where the acoustical impedance changes very rapidly. And in that case, you get a reflection again back from that corner, and it muffles your stereo image again. So we rounded off these very sharp edges. These are a few acoustical parameters that are very important, and that's the reason why the speaker looks like it is. It's not that we like this design and we made a speaker. No, we started from scratch and said, okay, what do we want in terms of acoustical behavior? And that's a typical form follows function speaker system. We integrate, and we do that for two reasons. One reason is just elegancy. Today's audio systems are different from, say, the 70s or the 80s, where you had a huge pile of preamps, cables, power amps, whatever, tape decks, record players. Today's music lover is really looking for a more elegant solution. That's one. The other one, the full advantage of integration is that you have full control as a designer over the interaction between amplifiers and speakers. They're not depending on the type of cable, the length of cable, which means that you can totally optimize the interaction. And the same holds for the filtering and conversion. What we can do as a designer when making an integrated system is just making a system with a very predictable behavior. Because everything else that you do is connect to source. And with this predictive behavior, we are sure that we have a more predictive result that you are listening to. And we can optimize the interaction between amplifiers and drivers. And that's what we did. We have filtering in the digital domain, and the result is a near perfect time behavior. If you look at the brochure that we have, you see an example of the step response, which is really, well, it's like the textbook shows you on how to design a filter. That's the acoustical response of the system. And that's what you hear in terms of phase purity of the playback. And that's one real big advantage over passive systems. Moreover, because we calibrate each unit where the say tolerances out of the drivers are calibrated out to optimize the frequency and phase response, and that's a manual process. It's labor intensive, and we do that by hand because there's a few deficiencies and tolerances from speakers that you better not compensate. They have a different acoustical background, and we have found that some of those should not be compensated for, while others can be perfectly compensated within the digital filter system. And once you know that, at least we as a designer, we have a very powerful tool, which is a DSP, and we can make a filter which is really using the best qualities of the filtering technique while avoiding the errors that you can make in a, say, automated calibration process. So that's why it's a manual calibration. Good, that's LS1 in general. We have a new model, which is the LS1 BE. We have developed together with Seas, the Norwegian driver manufacturer. We have developed a new tweeter, and we have upgraded the electronics, and I will go through that step by step. I'll start with the tweeter. The new tweeter membrane is beryllium, which is a very light and very stiff material. So it doesn't have any breakup at frequencies above 20 kilohertz. So the advantage is that you don't need to compensate for that. And that's always a bigger advantage than having them and compensating them. Apart from that, has a new driver, a new magnet system, which makes it easier to use also from the very low crossover frequency that we use. The result is 9 dB less distortion, and that's audible in all areas, say from voices, piano, and so on. On the electronic side, we have done a few things. We've been able to even further reduce the jitter of the main oscillator, which is responsible for AD and DA conversion. And we have substituted somewhere 40-50 critical parts for better components. Because we have some extra budget in this speaker, we can use better components, and they mainly are responsible for lower phase modulation distortion, which is a very complex type of distortion. But the result is a cleaner playback without the artifacts that you sometimes hear in terms of high frequency harshness. I think the most innovative improvement is the new subwoofer. In all LS1 systems, it's an active subwoofer, which means that it has its own amplifier included in the enclosure. We went one step further. When you have to move a lot of air for low frequency playback, you need to have a cone which makes big excursions. Alternatively, you can use big speakers and big cabinets, but we don't want that. We like elegant systems. So we stayed with a very compact cabinet with a 10-inch driver, and we applied what we call motion feedback technology. That's not new, it has been invented by Philips, but we apply it in a more rigorous way, where we achieve at the end a reduction of distortion of about 30 times. And you shouldn't be surprised if you have a normal passive system that you have on higher levels of playback, that you have distortions like tens of percents. That's not unusual. They're kind of pleasant types of distortion. They're not so audible, but once you reduce them, you really get the very clean, non-coloring, low-frequency playback, which is for some people you have to get used to it, but at the end of the day, it's so comfortable to listen to. It's really contributing to a very relaxed type of playback. Well, that's in a nutshell the LS1 BE. We've heard some beautiful music already played by Harry. I think if there are questions, please now feel free to ask them. Otherwise, we can always discuss in the hallway some specific details, and then I will ask Harry van Dalen to play some music again. Well, if there are questions, please go ahead.
Why do you angle them?
Okay, the toe in.
Yeah,
that's a good question. Thank you. That's a second step, an additional step that we take in reducing the reflections to the wall. If you toe them in, you have more directly radiated energy to the center of the room and less to the walls. The toe in here is what we call pretty aggressively. And if you look at, say, the on-axis response, you're not really sitting on axis. I'm just walking outside of the... we took care of that by calibrating the speakers such that the response at 15 degrees is straight. So the tonal behavior of the system that you look at is straight. It's only the optical perception that you have is like, okay, it's very towed in, But it helps you enormously in even creating a more fluid and precise stereo image. So that's the reason why we tow in. There's one extra advantage, there's actually two. Also, the reflections from the wall behind you are reduced. Normally, if you have a setup like this, you have a lot of energy to the wall behind you and you get the reflection back. Those are often forgotten in the stereo setups, so that's also an advantage. And another one is if you are a little bit more to the left or to the right, if you are sitting more close to this speaker, it's closer, so you will hear it, perceive it louder, but you're more directly looking into the speaker that's further away. So that's also becoming louder, which means that the loudness variations when crossing from left to right, the loudness variations are kind of balanced. And that's very pleasant behavior of a system, because it also means that you can move around through the room without the stereo image pulling with you. You can experience that by taking another position in the room when the music is playing. Okay. Yeah. Any other questions? Yeah.
There is a DSP inside.
Yes.
So maybe potentially it would be possible to do some active room correction.
Yes.
What is your vision on that?
We do have a clear vision on that. We're pretty convinced that it has advantages. Some of the, say, ugly behavior of rooms can be corrected in the electronics, but you have to be very careful. Still, we aim for corrections in the own domain. So if you have an acoustical problem, we are still convinced that it's better to solve it in the acoustical domain. And therefore you have to be careful with solving acoustical issues in the electronic domain, in this type of DSP, for instance. So in case you're doing that, you have to be experienced enough to really know, like, okay, this is a problem that we should stay away from. We cannot compensate it, and that's often a problem which occurs in one place in the room where you can perfectly solve it, but then if you move around to another area, it becomes worse.
Yeah.
So then you're actually more damaging something than you repair. Still, it is possible, but yeah, you have to be experienced. And the force of a DSP is like you can do everything. It's like a great tool, but you have to limit yourself to not compensate and correct everything because you can. No, you have to be very careful, and that's a tendency of humans in general. That's like, oh, I've got this tool, and now I'm gonna straighten everything out. No, you have to be very careful. But yes, it's possible, but it requires skills from the user or the dealer or whoever is setting up the system.
Okay, cool.
Yeah, other questions? All right. Thank you for your attention to this rather technical talk. I'll just give a sign to Hardy van Dalen so we can continue with some music.